Welcome to GitMap. We're gonna do heart disease classification. The data set we got from the UCI machine learning repository. I will highly recommend to check it out. It has a lot of the data sets, and this data set has a lot of different features and for different purposes. For heart disease specifically, it has 3 classes, but we try to make it binary classification. And the good thing is that it also has like the continuous and categorical variables, and it is a pretty good project in order to get our hands dirty with the data science projects. It is pretty popular again in the GitHub and in the Kaggle. So we're gonna start running the code together, and yeah, let's start it. So for this video, we're gonna use the UCI machine learning repository dataset for heart disease. In UCI machine learning repository, you would see a lot of the dataset which are open source, and they are used in Kaggle competition, or in the GitHub you would see some codes about that. They have been used for a while and they are pretty popular. And the dataset that we're gonna use is a Cleveland heart disease dataset. You would see that here we have 4 databases for the heart disease. Some of the people merged them in order to create the larger dataset, but here we're gonna focus on only Cleveland. So the characteristics are the same for all of the dataset. It has multi-variables, and the number of the attributes is 75. However, from the 75, we're gonna have only 14 attributes, which is processed and is available for us. If you want to download the dataset, then you would see these 14 variables in the dataset. And again, you can go to UCI machine learning repository, read over the data, and get understanding about each variables and the meaning of each variables. Just a simple explanation over here is that since we're gonna focus on binary classification, and this is multivariate, we're gonna convert this multivariate to binary classification, as I will explain later on. So this is just the overview about UCI machine learning repository and getting some understanding about that. Okay, let's go to the Jupyter. Here is some explanation about the variables that we have, and here is the dataset that we have, processed Cleveland dataset. We're gonna use this, and we're gonna try to predict basically the heart disease on the test set. But just remember that here we don't have any tests or train. We're just gonna use the whole data set and divide it to train and test in order to test the model and make sure the model is working pretty well. Okay, so you would see here that again we have a categorical and continuous variables. What we're gonna do is we're gonna get the data set, and then we're gonna explore them, the model, and finally get the result and evaluate the performance of the model. This is just a flowchart about what's gonna happen in this video. Okay, we start by importing the libraries. You will see here we added all of the libraries that we needed, and then here start reading the CSV file, basically Cleveland dataset. When you browse the data, you will see that there are some missing values. In order to read those missing values, we need to specify the type of them. Other than that, it's just gonna skip those missing values. So just make sure that you add any values here in order to make sure you would see all of the data using the pandas. And then here is some summary about the dataset to just see which variables has missing value, which one does not. And then here you would see that I try to get for example, the number of the major vessels, which you would see here has missing values, and get to see how they are missing in which types, and some understanding about those instances basically. And then we group them by the target. You would see that here we have 5 classes. As I said at the first, we have multivariable classes, so we have 5 classes in the target, and when you compare the number of the instances, you would see that here, for example, the number of the vessels is missing, 3 of the instances are missing. For class 0, for class 1 instance is missing, and then for class 2, 3, 4 we don't have any instances missing because the number matches with the other column. You can also get the idea from just count, group by target.count. And then here I tried to count each classes to just explain a thing here. So remember that we have multivariate problem here, and if we consider to classify the data set based on these 5 classes, we're gonna have really imbalanced data set, because you will see that in the 0 we have 164 instances. For the other classes we have a small number. For example, for the 5th class we have 13 instances, which makes it really imbalanced. But remember that for this video, our purpose was binary classification. We are just curious about if patient has disease or not any more classification. So we're gonna merge all of these classes together, and we're gonna keep this. In that case, our data set will not be imbalance, so we're gonna have the balanced data set. So this is just a quick explanation about that part. Now remember that for the vessels we had missing values, and also for thalassemia, from this explanation, or either from here, the summaries, you would see that we have missing values. We need to take care of them at the first. So we start by getting the basically the categorical classes and dividing the data for each categories. The best way to there are different ways to impute the missing values. One way is just remove those instances with the missing values. The other one is, for example, for one column or one variable that has missing values, you take mean or mod and then replace those missing values with that number. The best way, compare these two others, we are not talking about the advanced methods. The best way is to get basically to categorize or group by these values based on the target, and then get the mean based on that, and then replace that with those missing values, which is what we have done over here. Basically for each disease and non-disease, for a number of the vessels, we got the mean, and we replaced those missing values with this mean that we got from the overall class of that specific target. We did the same also for thalassemia. You would see that, but since the number for thalassemia is integer, we tried to get the integer of that and fill it out for the missing values. Eventually we merged them with the other classes in order to make sure we have the whole data set, and finally this is our data set. And you would see that when we count the target, after considering 2, 3, 4 as just the first class, we have 139 for patients with the heart disease and 169 with non-disease, which makes it balanced and also binary classification. And then we tried to draw the heat map in order to see if there is any correlation between two variables, and you would see that here this range is between 0.3 until 0.4, negative 0.4, and it is not more than 0.5, which makes like it not really helpful for us in order to make any decision based on this heat map. And then remember that last time in the Titanic, the suggestion was that to plot each variable based on the target to see how they are behaving based on the versus the target. Here we tried to plot age, for instance, and we can see that from this it looks like the binomial distribution. And when we plotted based on the target, based on the sexuality, we would see that men has more disease compared to the women, and even when we get the percentage, you would see that the men who has disease is 0.18, the woman is 0.09, which is pretty small number. So this gives you some idea about the data set, about how the distribution looks like, how different variables are affecting the disease or behaving about this disease, and so on and so forth. This is the pair plot, plotting each variables to just see how they are distributed. But from here, I don't see any correlation, anything meaningful, any two variables who are changing together positively or negatively. So it was just for visualization purpose, not much informative. And then you would see here that I tried to basically get the unique number for each column, and eventually, for example, for the target we have just 2 classes, for thalassemia we have 3 types, and so on and so forth. You would get idea about the categorical and continuous variables over here. And then this is just the overview of the data set. You would see how the data set looks like. We have about 300 rows and 14 columns. And now it's time to create the model. And before creating the model, when I checked out the other pages, they have done something crazy like this to create some dummy variables and then try to clean them up and eventually get the X and the Y. We didn't do this because actually I tried this, and the result that I got instead of this, just using the simple model, was better. That's why I kept just working with that, and I removed this part. But you can do this the same. The result gonna be a little bit off, maybe 1%, 2%, but you don't need this much work. Just a simple pre-processing would work, as we did here. And okay, so now that we have our data set with imputed the missing values and clean data, we try to get the X and the Y. We split it up to X train and X test, and we first standardize it. So there are 2 type of the scaling. One is normalization, the other one is standardization. Why we do any of this? Because if we have, for example, we have weight in the pounds, or like the other BMI in different scale matrix, the point is that we try to scale them in order to make sure they are not really different, and this can take care of it. So for min max, it is sensitive to the outliers, and for standardization, it tries to basically normalize it, and between with the variance at 1, standardize basically centers it to the 0 and standardize it around the 1 variance. So we tried to use a standard scaler rather than normalization in this work, because this worked better compared to the normalization. You can use that as well based on your data set. And then we did feature selection. So when the number of the features is a small number, here we have only 13. Maybe when you have 10, you don't need to do feature selection, but honestly, it depends on your data and the features. If you have some features that are noisy, you need to get rid of them. So anyhow, doing the feature selection is the best way to just make sure if you are getting better result, or if not, you can just keep them as it is. It doesn't hurt, basically. So after doing the feature selection, basically I used the lasso regression in order to do the feature selection. This was the best one to give me the better result. And lasso basically shrinks the features and gets rid of the some features, in opposite to the rich regression. But anyway, since we didn't use the rich here, so I will keep the lasso. And then transferred both of them, X train and X test. And one more thing that I forgot to tell you is that For standardization, make sure to standardize your data after you divided it to the train and test, rather than doing it on the simple X and Y. And we do that because if we standardize the whole data set in the X, basically you are somehow tricking the model. You are letting the model know the distribution for the test set, which is not accepted. So you shouldn't touch the X test for any types of the changes unless you have done like some split, and after that you can do a standardization and make your X test ready. But before than that, don't do any changes on your data set until you divide them to train and test. Okay, that was a hint. And then here are some machine learning models. As we saw in the Titanic, we have logistic regression, KNN, SVM, Gaussian naive Bayes, which is a new one here, but it doesn't work well. I just added it because it's a new one and it is used mostly as a basic classifier. And then the same MLP decision tree random forest, which gave us better results. And you will see that XGB did the worst, not the worst, but worse compared to the random forest. So important thing about gradient boosting, which I was reading about it, is that you need to really be careful about hypertuning parameter. If you don't hypertune the parameters, you are not gonna get the good results. That's why here I added all of the parameters for 3 important classification and try to tune them. After tuning the parameters for extra gradient boosting, you would see that I got better results compared to before than that. So here, after tuning the random forest, I got like 84% accuracy for cross-validation on the training set, and on the test set I got about 80% accuracy, and then based on just the gradient boosting I got 83% on the cross-validation and 82% about on the test set. You would see that disregard to this model of the gradient boosting, which we just did with the default, after hypertuning it, basically the hypertuned model worked pretty well even compared to the random forest, which was our best original classifier. So we go for gradient boosting and we use that in order to make the prediction. We use it and you would see this confusion matrix. So people who predicted to have a disease and actually have disease, 22 are 22, and then 28 of the people predicted not to have a disease and they didn't have a disease. 2 of the people predicted to have a disease but they didn't actually have a disease, and 9 of them actually had a disease but they didn't predicted to have a disease. So this is explanation about confusion matrix. I hope I got it right. Sometimes I confuse this one always between false positive and false negative, but anyway, I guess I got it, yeah. And then I explained this one as well. So thank you for watching this. Please wait for other videos. Hopefully this is gonna be helpful for all.